All right, hello everyone. Missy here again today, and we will be learning how to replace letters with numbers. So we have our agenda here. First is going to be the objectives. So I can fluently understand a letter represents one number in a specific expression. So that's what we're going to be learning, and that's what we're going to be able to do at the end of the lesson today. So throughout what we're learning, you will learn those materials to get you to fluently be able to understand that. So our materials we will need for today are paper, pencil, and eraser. And again, if you guys don't have that and you have an electronic device or anything to write with and write on, that would be great. So if you could just participate with us, anything counts. So for our riddle today, we have how many squares are there? So we're going to look at that picture and count how many squares there are. Really think about that because it can get a little bit tricky. So I will give you about 2 minutes to go and get those materials and figure out that riddle. So if you guys can pause here for that 2 minutes and we will come back and go over the answer for the riddle. All right, so coming back together, I'm gonna draw that figure out on my paper. It's not gonna be as great because I am not an artist. So when I look at it just straight at the picture, I definitely see 9 squares. So if you guys saw the same, these are the 9 squares I see. But there are more than 9 squares. So some of you may have said there are 10 squares because the border around is our 10th square. So the border is also a square, so that was 10, but there are 4 more. So I have my 11th square here, this group of 4. So 1, 2, 4, and 5. And then I have my 12th square, which is another group of 4, which is 2, 3, 5, 6. So this square. And then I have my 13th square right here. So 4, 5, and 7, and 8. And then I have my 14th square right here, as 5, 6, 8, and 9. So total, this riddle has 14 squares part of it. So let's start thinking. How can 3 times 3 be written differently? Think about that mathematically and what other expressions we can use to describe 3 times 3. And if 3 times 3 can be written differently, can we also write units times units differently as well? So I'm going to have you guys pause here for about 3 minutes as well so you could think about that answer and we will come back with that. All right, so I know that 3 times 3 equals 9, but that's not what they're asking me here. They're asking me how can I write 3 times 3 differently? So using our PEMDAS that we had learned previously, I know that 3 times 3 is also the same as 3 squared. So basically 3 squared means 3 times 3. So 3 2 times. 3 2 times means 3 times 3, which is also going to give us 9. So now that we know that 3 times 3 gives us 3 squared, units times units would probably be the same, correct? So I have units times units. And to write that differently, again, I get units squared. So for this, that's going to be great for us because we are going to need to know how to do that moving forward from here. All right, so using a square to show units. So using the image, how many units does one side of the square have? What formula do we use to represent the area of a square? And what is the area of a square written in multiplication expression? So if you guys don't know what some of these mean, that's okay. I would like you to try it on your own, give it the best try you can, and then I will go over it and teach you that after. So if you can pause here for about 2 minutes, and then we will go over that together. All right, so I have the answers here for you. So the image shown, it asks how many units does one side of the square have? So if I look at the square, I count 1, 2, 3 units on one side. And since it's a square, we know that all the sides are going to be the same. So I know that one side is 3 units. So that answers our first question. And our second question is, what formula do we use to represent the area of a square? So the area of a square is area equals side squared. So one side we know is 3 units, and then squared, we had just learned about it. I just showed you those on how to start thinking in the start thinking section, and the 3 times 3 is the same as 3 squared. So this is going to be side times side, which is the same as side squared. And we know that one side has 3 units. So what is the multiplication of the square written? What is the area of the square written in multiplication expression? So that's going to be 3 times 3, but they're 3 units. So then we have the 1, 2, 3 units on the top as one side, and you can use any other side. Usually I like to use the side that goes down if I'm using the straight across side on top. So then I have my 1, 2, 3 units also. So that can be written as 3 units times 3 units. And then if we wanted to write it in the formula that represents the area of a square, it would be 3 units squared. So I'll write that out for you. 3 units squared. So then that would give us the same answer as 3 units times 3 units. Okay, so moving along, this one is a little bit different. I do have the same questions here for you, but we did see in the past slide that it gave us boxes. So it gave us the boxes on how many. So on this slide, it gives us the side length without the boxes. So again, I will give you guys another 2 minutes to go over this on your own. So using the image, how many units does one side of the square have? What formula again do we use to represent the area of a square? And what is the area of the square written in multiplication expression? So pause here for 2 minutes and then we will go over that together. All right, so we know that one side of the square is 15 units because that is shown right on top for us. So we didn't need the boxes for this one because it already gave us how many units it was. So since it was a square again, all sides are going to be the same. So 15 units on all sides of my square. So what is the formula we use to represent the area of a square? Again, it's going to be the same as the previous slide. Area equals side squared. So it would be side times side or side squared. And then what is the multiplication? What is the area of the square written in multiplication expression? So that would be 15 units times 15 units, also 15 units squared. Is the same thing that we have written both times. So that's going to be just a little bit of a background on how we figure out the units, what the formula is, and how we're going to multiply it to get us to the answer. So now we are going to use letters to connect with numbers. So I have written here that the whole side length of the top part of the rectangle is going to be 10 centimeters. So since I know that's 10 centimeters, the bottom that says BCM, so the B is going to represent what the number is going to be. So they want to know what B is. So since we know the rectangle has two sides that are the same and then the other two sides that are the same, here the opposite, which is going to be the same side of 10 centimeters, will also be 10 centimeters. So our B in this instance would be 10 because it's the same as the top side length, which is 10 centimeters. And then next to it, we have like a chart-like picture. It's also a rectangle, but this one's showing you how many centimeters the units are in each section. So it says X centimeters for the whole top portion. So we want to fill in what X is. So we know that one part of the rectangle is going to be 4 centimeters and we have 4 parts. So if I know that's 4 centimeters, and then they want to know what the entire rectangle is, and I know it's split into 4 parts, what I can do is use this formula, do 4 centimeters by 4 centimeters, because I know that each one of these rectangle units are going to be 4 centimeters, and there are 4 of them. So X for this instance is going to be 16 centimeters. So that's how we connect units, numbers to our letters using the length of a rectangle and certain parts of the rectangle to find the entire rectangle side length. So moving forward, I want you guys to find that answer on your own. So we're going to find the answers to represent B and X in the images. So these images are a little bit different than the ones that we just have done. It looks about the same, but the numbers could be different. So on the green rectangle, I have 13 centimeters and then B centimeters. And then for the yellow rectangle, I have one part of that being 3 centimeters. And then they want to know what the entire side length of that rectangle is, representing X. So you guys will pause here for 3 minutes to go over that, and then we will come back together. All right, so coming back together, so my 13 centimeters is parallel to my BCM, so I know it's going to be the same as the 13 centimeters because they are parallel to each other in the rectangle. So I know B is going to be 13 centimeters. And then for my X and my 3 centimeters and my yellow rectangle, we are going to count how many sections it's divided up into. So I counted 1, 2, 3, 4, 5, 6. And then I know one of those 6 is going to be 3 centimeters. So what I would do here to find X, which is the entire side of the rectangle, and on the bottom when it gave us a 3 centimeters, I only got 1/6 of that answer. So I would do 3 centimeters times 6, and that would give me 18 centimeters. So I know that X is 18 centimeters. All right, continuing on, we're going to use letters to solve. So for the formula for volume to solve the answer is volume equals length times width times height. So moving back to our very beginning when we did the start thinking section, we did the units times units, and that gave us the answer units squared. So that's really important when you're using volume and we're using area, because you have to make sure you add in those units squared. So in this instance, for volume, we know it's length times width times height, and I have that picture out for you. And then I do have the numbers next to it. So what we're gonna have to do is write units times units times units, and that's gonna give us units cubed. So for volume, it's going to be cubed. So we know that in this picture, our h is going to equal our height, and our height is 7 centimeters. So I like to write out all my information before I start doing the problem, so I make sure I have everything I need to succeed. So our W is going to be our width, and the width in this instance is going to be 3 centimeters. And then our L, which is going to be our length, is going to be 5 centimeters. So I have all of that written out now. So I know that H correlates with 7 because it's the same. So H is 7, W is 3, and L is 5. And then don't forget, we need the centimeters as well. So our volume, which is V, equals length times width times height. So I'm going to plug in those numbers. So my length is 5 centimeters times my width, which is 3 centimeters, times my height, which is 7 centimeters. And then when I multiply those all together, it's going to give me the answer. So I like to do it in a row. So I'm going to do V for volume equals 5 centimeters times 3 centimeters. So that gives me 15 centimeters squared because I have my 2 centimeters and I'm multiplying both my numbers. And then I'm going to have times my 7 centimeters. So I like to do it like this. Since multiplication is commutative, so you could do 3 times 7 first if you wanted, but I just like to go in line so I don't get confused. So now my volume, again, V equals 15 centimeters squared times 7 centimeters. So 15 times 7 is going to give me 105, and then I have my centimeters squared times centimeters, which gives me centimeters cubed. Just like that. So that's how we connect our letters to our numbers, and then how we use those numbers to find the answer for the question. And in this instance, it was the answer for volume. So moving along, we are going to find the volume using the measurements given. So earlier in the previous slide, I had the units and the letters written out on the diagram. So now we are going to connect the units that they gave us to our diagram, and then we are going to find our answer for volume. So I am not the best at drawing this, but I will give it a try. Okay, so it wasn't too bad, actually. So we have our H, our W, and our L. So it says our height is 10 centimeters. So height is H, so that means this right here is going to be 10 centimeters. And then it says our width is 4 centimeters and our width is W. So that's going to be here, and that's going to be 4 centimeters. And then we have our L, which is length, and that's going to be here, and that's going to be 6 centimeters. So now that I connected all of our units to our letters, now we are going to find the answer for volume. So again, I know volume equals length times width times height. So when I plug those in, I have volume equals 6 centimeters times 4 centimeters times 10 centimeters. Length times width times height. My length is 6 centimeters. My width is 4 centimeters. My height is 10 centimeters. And then now we do the math. So my volume is 6 centimeters times 4 centimeters, and that's going to give us 24 centimeters squared times 10 centimeters. So after we do that, we do 24 times 10. So then our volume equals 240. And then I have centimeters squared times centimeters, which gives us centimeters cubed. So our volume is 240 centimeters cubed. So once you understand that you need to multiply the units along with the numbers, you will always get those correct no matter what. And in these problems especially, it's super, super important that you do include the units because that's going to be one of the most important parts of your answer. So some teachers may give you like a half a point off because you didn't do your units. So it's really important because those can add up eventually. So let's do a challenge. Use the measurements to draw your own image and solve. So I'm going to give you guys about 5 to 7 minutes, however long that you feel that you need to take these numbers, put it into a picture, use the right units connecting to the letters, and then solving. So you guys can pause here for about 5 to 7 minutes, and then we will go over it together. All right, so moving forward, I hope that was enough time for you guys to complete that challenge. I know it was a lot. I gave you 2, so if you only were able to get to 1, that's okay. You know, you can do the second one later if you didn't have enough time to finish that right now, but it gave you guys an opportunity to try it twice. So I have it drawn out for you. So in our first equation, our height was 9 centimeters, our width was 3 centimeters, and our length was 6 centimeters. And in our second challenge question, our height was 12 centimeters, our width was 5 centimeters, and our length was 8 centimeters. So if you guys had something like this, the same, that would be perfect. Your image might look a little bit different. It is kind of hard to draw 3D figures. So if your drawing wasn't perfect, that's okay because we're not testing you or asking you to draw pictures. We're just having you connect the image to the numbers and the letters. So for finding the answer for the volume challenge questions, for the first challenge, I have volume equals 9 centimeters times 3 centimeters times 6 centimeters. So then I get volume equals 27 centimeters squared times 6 centimeters. And when I multiply 27 times 6, I get 162. And then centimeters squared times centimeters gives me centimeters cubed. So again, it will look like this when you write it. It was a little bit difficult for me to try to insert it into the PowerPoint, but it will look like this. Centimeters cubed goes up here. So the little caret shows it's going to be like on top, and then I did the 3. So then for the second challenge question, I have volume equals 12 centimeters times 5 centimeters times 8 centimeters. So then 12 times 5 gave me 60 centimeters squared, and then times 8 centimeters. So then 60 times 8 gave me 480, and then centimeters squared times centimeters gave me centimeters cubed. So make sure again that those units are super, super important because then if you didn't write that, I wouldn't have known it was the answer for a volume question. So our objective again was I can fluently understand that a letter represents one number in a specific expression. So going back and looking at what we did with the volume question, we had the length, height, and width, and then that had one number that correlated with each letter, with the length, with a height, with a width. So that's how one letter represents one number in an expression. And then if you guys wanted more practice, again, my 2 favorite are Brain Pop and Khan Academy videos. videos. Brain Pop is a little bit more animated, and then Khan Academy videos are like teachers teaching to you the concepts. So thank you so much.